This video is going to be about Type 1 and Type 2 supernovae. We'll start out by describing Type 1a supernova. One thing that distinguishes a Type 1a supernova from other supernovas is the fact that it has no hydrogen absorption line. This is because Type 1a supernovas normally occur in old low-mass stars which have consumed all of their hydrogen. Type 1a supernova result from the accretion of matter in a binary star system. The members of this binary star system, one must be a white dwarf and the other can be either a giant star or a smaller white dwarf. Type 1a supernova show up as a rapid increase in luminosity followed by a gradual tapering off of luminosity. All the luminosity of Type 1 supernova is the same, which makes them useful as standard candles to measure distances to distant galaxies. The reason they all have the same luminosity is this. If I have a dense white dwarf that pulls material from the other star, it can do this until it exceeds the Chandrasekhar limit of 1.4 solar masses. Once it exceeds 1.4 solar masses, it starts up a fusion reaction, which then blows the star apart in a supernova. Because this supernova always happens at a known mass of 1.4 solar masses, that means we know the luminosity, and we can use apparent brightness to find the distance to that supernova. Shown in the picture here is a Type 1a supernova. So we have a white dwarf and a larger star, which it's pulling material from until it exceeds 1.4 solar masses, the Chandrasekhar limit for a white dwarf, and then we have a supernova. The other kind of supernova you need to know about is a Type 2 supernova. Unlike a Type 1a supernova, Type 2 supernova have hydrogen absorption lines in their spectra. This is because they occur in young high-mass stars that have become unstable. Once the high-mass star can no longer keep its fission reaction going because it doesn't have a sufficient amount of fissionable fuel, the star begins to collapse under the pull of gravity due to the loss of hydrostatic equilibrium. Because this star exceeds the Chandrasekhar limit of 1.4 solar masses, electron degeneracy is insufficient to oppose the pull of gravity. At this point, electron capture occurs, where neutrons and neutrinos are created from protons and electrons. The star collapses inwards further as electron capture is creating neutrons and releasing neutrinos, and then the neutron degeneracy pressure pushes outward, causing an explosion. A Type 2 supernova is less luminous than a Type 1a supernova. Additionally, there's this plateau in its curve, which occurs a few days after the peak luminosity, which is followed by a rapid decline in luminance. Alright, that's the end.